right, so 8.4 starts off by talking about binomial coefficients or the binomial theorem, which is these. We talked about this with probability. We've seen this formula before in probability. We're not going to do this for the tests. So we're going to skip example 1, example 2, and go to example 3. And we're going to talk about Pascal's triangle. All right, so we're going to talk about Pascal's triangle. Pascal's triangle is this here. It's a triangle that helps us expand binomials raised to a certain power. So the first row here, this is actually our 0 row. I'll call it row 0. Next one would be row 1. Next one is row 2. So notice how row 2 has a 2 as the second number. Whatever the second number, it tells you what row it is. So whatever the second number is, that's what row we're talking about. So this one would be row 2. Now, you have to come up with Pascal's triangle. So I'm not asking you to memorize this, but you do need to know how to come up with it. So what we would do if we didn't have Pascal's triangle in front of us. To come up with Pascal's triangles, we start with a little triangle of ones. 1, 1, 1. Every row is going to start and end with a 1. So the next row is going to start with a 1. The next number adds the two numbers right above it. So 1 plus 1 would be 2, and then our row is going to end with a 1. The next row starts with a 1. We add the two numbers above it, so 1 plus 2 would be 3. 2 plus 1 would be 3, and it ends with a 1. The next row starts with a 1. Every row starts with a 1. 1 plus 3 would be 4. What's 3 plus 3? 6. 3 plus 1? 4. And then 1. The next row starts with a 1. Add the two numbers above it, so this would be 5. 4 plus 6 is 10. 6 plus 4? 10. 4 plus 1? 5. And then it ends with a 1. And so on. So we could come up with the 6th row, the 7th row, and just keep going. As long as you know the pattern, coming up with each row is not challenging. Just need to start with your little triangle of ones and make sure you know that each row is going to start and end with a 1. So Pascal's triangle helps us come up with the coefficients when we have a binomial raised to some power. So notice here in the example, if we had anything raised to the 0 power, it would just be 1. That's why we start with the 0, row 0. The next row, our coefficients are 1 and 1. The second row, our coefficients are 1, 2, 1. Third row, 1, 3, 3, 1. Just like we had in our Pascal's triangle that we drew. So this helps us with the coefficients. It's not always going to be the case that we're starting with coefficients of 1 as just x and y, but I'll show you what we do when it's not as easy as just x plus y. Let's look at example 3. So there's 3 things that we need here. We have our first term, our second term, and the exponent. The exponent tells us what row we're looking at. So here we're looking at row 3. We just drew it up here, row 3. So we're looking at this row here, these coefficients. So my coefficients are going to be 1, 3, 3, 1. So I'm going to write that here. 1, 3, 3, 1. Now I'm going to take my first term, x. I'm going to put an x right below each one of my coefficients. Now whatever exponent is, that's what the exponent of my first x is going to be. So this is going to be x to the 3rd power. And then we're going to decrease from there. So x to the 3rd power, x to the 2nd, x to the 1st, and then x to the power of 0. Then we have 1. So that's going to have its own row here. I'm going to have a row of 1s. But it's going to be the opposite. We're going to start with 0, and go up to 3. So we have 1 to the power of 0, 1 to the power of 1, 1 to the power of 2, and 1 to the power of 3. Notice how the exponents in each column all add up to what? What's 3 plus 0? 3. What's 1 plus 2? 2. What's 2 plus 1? 3. And 3 plus 0? 3. They all add up to what? 3. That's always going to be the case. So you can always check your work that way. Your first row, your first term, starts with your exponent that you have. So it starts with 3 and decreases. The second term, so 1, starts at 0 and increases. And each column is going to add up to the exponent of 3. So now each column represents each term that we have. So with our first column here, I'm going to multiply all of these things together. What is 1 to the power of 0? 1. So this is just 1. So we have 1 times x to the third power, which would just be x to the third power. Since our sign is plus, we keep it as a plus sign in the middle. Then our next term, we're going to multiply these 3 things together. So 3 times 1 would be 3 times x squared. Our next row, we're going to multiply these 3 things together. So again, we have a plus 3. 1 squared is just 1, so 3 times 1 is 3. And then x to the first power would just be x. And then what is x to the power of 0? 1. And 1 to the power of 3 would just be 1. So 1 times 1 times 1 is 1. So this would be our answer. If we sat here and multiplied x plus 1 times x plus 1 times x plus 1 to the third power, so we've got 3 of them, this is what we would get. When you have x to the third power, it might take the same amount of time to just FOIL it all out. But if you had something like x to the 5th power, it's going to take you a long time to FOIL it out. Using your Pascal's triangle shortcut is going to be a lot easier. So example 4 is super similar. We still have x minus 1 to the third power, so our exponent's 3. So we're looking at row 3 of Pascal's triangle. What are the coefficients going to be in the third row? What were they for the last one? 1, 3, 3, 1. Now our first term is x, so I'm going to start with x to what power? X to the third power, perfect. And we're going to decrease from there. So then x to the second power, x to the first power, and x to the power of 0. Then I have a negative 1 as my next term. If you want to, you can keep the negative with it. So I'm going to say negative 1. Or when you practice more of these, you'll start to notice the patterns with the signs. But one way to make sure you're always right is just to keep the sign with it. So we've got negative 1. What's our first exponent going to be on the first negative 1? 0 to the power of 0, then to the power of 1, 2, and 3. So let's combine all of our columns together. What is negative 1 to the power of 0? 1. So I have 1 times x cubed, which would be x cubed. What's negative 1 to the power of 1? Negative 1. So we have negative 1 times 3 would be negative 3 times x squared. Then what's negative 1 squared? Positive 1. So positive 1 times 3 times x to the first power, just x, would be just 3x. So plus 3x. And then what's negative 1 cubed? Negative 1. And what's x to the power of 0? 1. So we have 1 times negative 1 would be negative 1. So this would be our answer here. So when you have a minus in the middle, your signs alternate. So it starts with a positive x cubed, then it goes minus, plus, minus. Let's look at example 5. So I'm going to start with my exponent. Here my exponent is 4. We can go back to the triangle that we drew before, but if we didn't have one, let's make our own here. We start with a little triangle of 1s. Next we have 1, 2, 1, 1, 3, 3, 1. What row am I going until? The 4th row. So I need my second number to be 4. So then 1, 4, 6, 4, 1. So these are going to be our coefficients. 1, 4, 6, 4, 1. My first term here is 2x. So I have 2x to what power? To the 4th power. Then 2x to the 3rd power. 2x to the 2nd power. 2x to the 1st power. And 2x to the power of 0. Then our second term is -3. So I'm going to keep the negative with it. We have -3 to what power? 0. -3 to the 1st power. -3 to the 2nd power. -3 to the 3rd power. And then -3 to the 4th power. So now we're going to combine all of the rows together. Make sure you're paying attention here. A common mistake that people will make is that they won't distribute the 4th power to the 2 and the x. Most people will just say this is 2x to the 4th power. But it's not just 2x to the 4th power. We have to distribute that 4th power to the 2 as well. What's 2 to the 4th power? 16. So this is 16x to the 4th power. So I'm going to rewrite that here. 16x to the 4th power. What's -3 to the power of 0? 1. So this is 16x to the 4th power times 1 times 1, which would just be 16x to the 4th power. We're going to do it again in the second one. So here I'm going to distribute the 3rd power to the 2 and the x. Don't forget to distribute it to the 2. That is the most common mistake that people will make with these types of questions. What is 2 to the 3rd power? 8. So we have 8x to the 3rd power. So I've got 8x to the 3rd power times 4 times -3. So 8 times 4 would be what? 8 times 4 is 32. Times -3 would be -96. So -96x to the 3rd power. So you just multiply all the numbers in the column together. Let's go to our 3rd column. I want to distribute the 2 here. So what's 2 to the 2nd power? 4. So we've got 4x to the 2nd power. And then -3 to the 2nd power would be what? 9. So we have 6 times 4x squared times 9. So 6 times 4 would be what? And 24 times 9? 216. So this would be plus, because we're positive now, 216x squared. Let's go to our 4th column. So 2x to the 1st power is just 2x. -3 to the 3rd power would be what? -27. Awesome. So we have -27 times 4 times 2x. Would be -216x. Now let's move on to our last column. What's 2x to the power of 0? 1. So this would just be 1. And -3 to the 4th power? 81, awesome. So 1 times 1 times 81 is positive 81. So this would be our answer. Notice the signs. Our first term is positive, then it goes minus, plus, minus, plus. The signs alternate. So that's one way that you can check your answer with the signs. It's not always going to be the case. If we were to throw in a negative in front of the 2x, it then won't alternate. So just be careful with the signs. Yeah. But if it's just a minus in the middle, that's the only negative you have, the signs are going to alternate. So you can check your work that way. So what's our exponent on B? 5. So we're looking at the 5th row for Pascal's triangle. So I need to add one more row here. So what's my row going to start with? 1. 1 plus 4 would be 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5, and 1. So 1, 5, 10, 10, 5, 1. So these are going to be my coefficients. 1, 5, 10, 10, 5, 1. What is my first term? X, so it's going to start with x to what power? X to the 5th power. So this is going to be my row of x's. I start with x to the 5th power, and we decrease from there. So x to the 4th power, x to the 3rd, x to the 2nd, x to the 1st, x to the power of 0. My second term is going to be negative 2y. So negative 2y to what power? To the power of 0. Negative 2y to the 1st power, negative 2y to the 2nd power, negative 2y to the 3rd power, negative 2y to the 4th power, negative 2y to the 5th power. In this step, you can check your work to make sure each column, our exponents, add up to 5. So 5 plus 0 is 5, 4 plus 1 is 5, 3 plus 2 is 5, 2 plus 3, 1 plus 4, 0 plus 5, they all add up to 5. So that's one way you can check your work. Check yourself in the middle. There's a lot of little math going on. If you make a mistake in this step, it'll throw off everything in the next step. So just check your work as you go. Negative 2y to the power of 0 would just be 1. I always like to just cross off the power of zeros just to get those out of the way. They're just going to be 1, so you can get rid of them. So in our first column, we have 1 times x to the 5th power. So this would just be x to the 5th power. Next column, we have 5 times x to the 4th power times negative 2y. So here, I'm going to multiply my coefficients together. Negative 2 times 5 would be negative 10. X to the 4th power, y. When you have multiple variables, just keep them in alphabetical order. You can put your x's first and the y's second. In my third column, what do I have to do with the negative 2y squared? Distribute. We're going to distribute the squared. So what's negative 2 squared? Positive 4y squared. So we have 10 times 4 would be 40, so positive 40, x to the 3rd power, y to the 2nd power. Next, same thing with the next column. We have negative 2y to the 3rd power. I have to distribute. What's negative 2 cubed? Negative 8y cubed. So negative 8 times 10 would be negative 80, x to the 2nd power, y to the 3rd power. Next, we have negative 2y to the 4th power. We have to make sure we distribute. What's negative 2 to the 4th power? Positive 16y to the 4th power. So here I have 16 times 5. What's 16 times 5? 80, awesome. So plus 80xy to the 4th power. And then we got to distribute the fifth power here. What's negative 2 to the fifth power? Negative 32, perfect. Y to the fifth power. So negative 32 times 1 would be negative 32y to the fifth power. Now we can check our answer. Do our signs alternate? Start positive, negative, positive, negative, positive, negative. Yep. So since it was a minus in the middle, your signs are going to alternate. Now that might not be the case if the first term's negative. It might throw it off a little bit. So just be careful with the signs.
Are those two numbers always going to be the same with opposite signs?
Not always. Not always. It happens in these two examples, but it's not always going to be the case that you have a coefficient repeat.